Today we're going to talk about Venn diagrams. Venn diagrams are visual relationships between sets. Here are a few that are shown. In this first one, you'll notice we have superheroes. Some superheroes have dead parents, wear red, they are rich, and they fight crime. You'll notice how certain circles overlap each other. That Venn diagram graphically shows you quickly what characteristics match up. On this second one, you have a typical Venn diagram that is set up using math with numbers in the overlapping circles. On this third Venn diagram, you would see a Venn diagram that could be used in the sciences, comparing whales to fish. Notice in this center section it says they both live in the ocean. That is called their intersection. That's what they have in common. Now, when you draw your own Venn diagram, you normally start off by drawing a rectangular box. This represents the universal set, and we normally put the letter capital U somewhere in or beside that box to represent the universal set. The universal set would include all the items which are called elements. Let's say we have the two circles, and the two circles are going to be labeled A and B for sets A and B. Now I'm going to put in some numbers, maybe a 1 and a 2 outside, and then maybe a 3 and a 4, maybe a 5 and a 6 in the center, a 7 and an 8. So you'll notice that some circles are shared by A and B, and some numbers are outside of both A and B. Now, the set of all elements in the universe that's not in the set A is called the complement of A. Here would be set A and set B, and the box, the rectangle, represents the universe or the universal set. The complement of A is everything outside of A. So if I went in here to shade the complement of A, I would have to shade everything outside of that circle. The complement of A is represented by A with the accent or the prime mark. The set of elements that would be common to both set A and set B would be called their intersection. That's where the two circles overlap. So that is the intersection. It is symbolized by A intersection B. The set of elements that are in either set A or set B or both sets is called their union. So again, if I have A and B in the universal set, their union would be everything in A, everything in B, and everything that they share in common. So that is the union. It is symbolized by A union B. Now we're going to use this Venn diagram to write a set A in roster form. If you recall, roster form uses brackets. So we want everything that's in this set A. That would be the numbers 3, 6, 8, and 10. No other numbers were inside the circle A, so they are not inside the set A. Now let's use this Venn diagram to represent the set of A intersection B. If you recall this symbol, it means intersection, so that's where the two circles overlap. That would be just these two numbers, 9 and 10. Now we're going to talk about a math tutor who's been working with a small group of students, and they were surveying these students and asked them if they had studied over the previous weekend. You'll see the responses given in the Venn diagram. So the question is, who studied on Saturday or Sunday? Now, those who studied on Saturday were Aaron, Jess, and Josh. Those who studied on Sunday were Jess and Josh again, Zach, Mary, and Lisa. So if we wanted all the students who studied either on Saturday or Sunday, then it would include all of those students. So we have Aaron, Jess, Josh, Zach, Mary, and Lisa. If you notice, that looks a lot like the union. Normally the word or implies union, and if we had seen the word and, that implies that we need to take an intersection. Now here's another survey. These are the results of the Roper Public Affairs and Media Survey of American Adults taken October of 2012. It says, how do Americans feel about pets? Some like cats, some like dogs, some like both. Notice right here the 60% in the middle, those would be the people who like both the cats and the dogs. But the question is this true? 60% of those surveyed like cats or dogs. Now think about it. The word or means cats or dogs. Now, if you like cats, that would be all of these people. If you like dogs, that would be all of these people, because I said the word or implies union of two sets, and that's way more than the 60%. So this statement is false. More than 60% of the people like cats or dogs. Now in this example, we have a survey and a schedule of musical instruments that are taught on certain days. Question A says, how many instruments are not taught on Wednesday? Well, these are all of the instruments taught on Wednesday. The instruments not taught on Wednesday would be piano, lute, and bass. So there would be 3 instruments not taught on Wednesday. Next, how many instruments are taught on both Tuesday and Wednesday? So that's a combination of both Tuesday and Wednesday. And remember, if we have the word and though, that means intersection. So they are taught on both Tuesday and Wednesday. The only ones taught both on Tuesday and on Wednesday would be the tuba and the djembe. And which instruments, last question, would be taught on neither Tuesday nor Wednesday? That would be these 2 little instruments outside of the circles. So that would be the lute and the bass. Now in this Venn diagram, we have 3 sets. We're looking at the genres of literature certain people like. Some like nonsense, some like romance, and some like fantasy. Question A asks, select the genres that Scott does not like. Now, if we locate Scott here, Scott is right here. Notice he falls within the circle of liking fantasy and within the circle of liking nonsense. The only circle that he's not included in is the romance circle. So that is the genre that he does not like. How many students only like fantasy? If you look at the fantasy circle, some of these students overlap with other genres, but we want the students who only like fantasy. Those students would be the 3 at the bottom, Raphael, David, and Raina. And last but not least, which students like neither nonsense, nor romance, nor fantasy? That would be outside of all 3 circles. And that would include Aldo, Nicole, Hans, and Laura. Now in this survey, we don't have the Venn diagram, so we may have to do some calculation. It says, I have a survey of 109 college students, and that was taken to determine where they got their daily news about what's going on in the world. Of those surveyed, 109 total, 28 of those students actually got their news from the newspapers, and 33 got their news from the TV, and 10 got their news from both the newspaper and the TV. So you see, we could construct a Venn diagram with two circles. One circle would stand for newspapers. The other circle would stand for TV. The 10 in the middle that get their news from both of these avenues would be right here in the intersection between newspapers and TV. Now, since 10 of those students are in the middle, I will need to subtract that 10 from the total on the newspapers. So that means I have 18 students who only read the newspaper. Now, if you look at them together, though, 18 plus 10 would give me the total of 28 newspaper people. Likewise, I need to subtract my 10 overlap students from the TV. And that would tell me that I have 23 students who only watch the TV for news. However, if I look at the 23 plus those 10 overlap students that do both modes, then that would give me the 33 total in the TV. Now, this is definitely not 109 students. If I take my 109 total and I subtract out the 18 newspaper only, the 10 who were newspapers and TV, and the 23 TV only people, let me do that quickly on my calculator, I will get 58. Now, that's 58 students who would be outside of these two circles. Apparently, these students must get their news from an app or from some other mode, from word of mouth. Now, the question is, how many students got the news from only the newspaper? The answer would be, as you can tell from our diagram, 18 students.